Okay, now for your video on momentum and impulse math. Start out here with the basic formulas for momentum, which is mass times velocity. The formula for impulse, and we call it a formula because it's not really a formula, it's more of an understanding that impulse equals our change in momentum. So when we have a change in momentum, that is the impulse. And to calculate the change in momentum, we're going to use this formula, which is really a formula for force, but we can calculate any of these three variables by plugging them into this magic equation, or magic, not magic, it's just triangle. But so the formula here that we're going to use is the force equals the change in momentum divided by the time. So we're going to plug these in. We'll start out with this top one and populate the triangle. And so in this triangle, the two bottom squares represent the variables that are multiplied by each other. So in this case, it's going to be the mass. It's going to be multiplied by the velocity. And then by default, then that puts the momentum up top. So then, of course, you use the circle to cover up the variable that you want to solve for, and that will show you the math to do to solve for that variable. So if we want to solve for, in this case, the velocity, we cover up the velocity. That gives us momentum divided by mass. If we want to solve for the mass, that gives momentum divided by velocity, and of course we already know that mass times velocity is going to give us our momentum. And so likewise, we can plug in these other variables for this other formula into this. Now here you have change in momentum on top of a line and time below the line. So think of this line as like this line. So this one that's on top of the line needs to go on top of the line here, and these two can populate either of these two boxes. It really doesn't matter, but the process for figuring out your new math, if I cover up time, I've got change in momentum divided by force. Cover up force, that's the formula we started with. And if I want to solve for the change in momentum, it's force times time, which is in your notes as well. So that's how we're going to use this. And because we're going to start our math examples with the other formula, we're going to go ahead and put these back and populate this one again. Oops, that one goes up there. And that's populated and ready to go. So we'll start out with our momentum. And here's our variables. So this is pretty straightforward, just like we did the last time. We're going to solve for momentum, and we're given a mass and a velocity. And our formula is mass times velocity. So we will just plug these in. 30 kilograms times 5 meters per second gives us a momentum of 150. And the formula, or the unit for this, is kilograms times meters per second. Nothing, no special unit for that. Okay, move on to the next one. I'm going to do one of each of the types. So that was question 3. This is question 6. Notice, keep track of the number up here so you don't mess it up in your math handout. So you're responsible for 4 and 5, which are exactly like 3. So this is 6. 6, it's asking you to solve for, this time, mass. So it's going to give you the momentum. And it's going to give you the velocity. Going to ask you to solve for mass. If you need to go back and do your magic triangle, you can. Move your little thing. Solve for mass. You're going to take momentum divided by velocity this time. So that means your formula here is going to be mass is going to equal your momentum divided by your velocity. Plug that in. Now you just got to plug in the numbers, right? Kilograms times meters per second divided by 2 meters per second. This cancels out, and you end up with a mass of 10 kilograms. And then the next one, number 9, so you're responsible for 7 and 8, is asking you to solve for the velocity. So the question mark goes by velocity. It gives you a momentum of 48 kilograms times meters per second, and it gives you a mass of 6 kilograms. So our formula, we can go back to our magic circle if we need to. Move this. We're going to solve for velocity, so it's momentum divided by mass. velocity equals momentum divided by mass. Plug in our momentum and our mass, and we end up with a velocity of 8 meters per second. Alright, now our next set of formulas, we'll go back over here and we'll switch our magic, put these back. Populate this one goes on top of the line, this one goes underneath the line, this one goes in whatever box is left, and we'll start out solving for, I believe, force. And yes, in question 12, it asks us for force, and again, you'll be responsible for 10 and 11. So we solve for force, question mark by the force, it gives us a time of 10 seconds, it gives us a momentum of 400 kilograms times meters per second, and you're going to end up with a Newton meter or kilograms, which can be converted in, which is the weight, and in the meters. So here we go, the formula for that. As I said, we come back over here if we forgot, and we look and we see that it is a change in momentum divided by time. So our change in momentum was 400. So for the force, we got the change in momentum divided by the time, 400 divided by the time of 10, and we end up with 40 newtons. Remember, the unit for force is newtons. Next one here is going to ask us to solve for the change in momentum. So it gives us a force of 40 newtons. Gives us a time of 5 seconds, and it asks us to solve for that one. If we don't know it, we go back over, we move and it's force times time. And it's force times time. So then we just plug our numbers in. Very, very simple. 40 newtons times 5 seconds, and we end up with a change in momentum of, in this case, 200 kilograms times meters per second. Okay, and then last but not least, we are going to solve for time. So we got, again, this time is 1200 kilograms times meters per second. That's our change in momentum. Our force is 40 newtons, and we're going to solve for time. One more time back to our triangle. We move that down here. We got change in momentum divided by force. So our time is going to be our change in momentum divided by our force. Plug our numbers in. 1200 divided by 40 newtons. 1200 divided by 40 is going to be 30. So our time is going to be 30 seconds. And that is the examples of one of each of the ones. So the rest of them are up to you. And then you'll be taking your district assessment after this. So good luck on all that, and I will see you on Wednesday.